So this is that 64 JMI Era AC4 I've been looking forward to getting to for a while. I'm going to take the chassis out so I have better access. I'm going to disconnect the tremolo foot switch first. Just have one less thing dangling and getting strained and potentially broken. Alright, so there's the tremolo goes to the egg. And we'll disconnect the power cable as well, but in this case I'm replacing this old UK cable with a new US cable. That of course has a 110 volt setting. So I'm just going to snip those, and those will tell me where the old leads went. And this should just fish out through this little clamp. Let's see. There it goes. Just let that go to the side. It's a non-original plug on it, so it's original cable with a tacked-on plug and then a US adapter, and we can do better. And this is something I've not run into before. Let me move the camera to show you. It's got this inline terminal connecting to the speaker. Now Vox used terminal blocks like this. They're usually attached to the chassis. I wonder if this used to be. We'll find out, but I'm going to disconnect it right here. And we're going to revisit this concept a little bit later in the service. Both sides of this will get addressed later. Now there are two nuts here and here which are holding the chassis in place, and this slider board will come out if necessary. I've got a 5/16 inch socket on a right angle. Let's see if this fits and works. Sometimes the old JMIs have a different size nut. Not metric, not SAE. I forget the name. Note to future self. Take the slider board out first next time. Well, now I know, and now you know. Okay. Slider board to the side. Carefully lower this down. Okay. And I'll get in there later and get all the cobwebs and spider egg sacs out and make sure all the hardware holding the baffle to the cabinet is tight. Let's see here. This output transformer connection is not original. And I don't know why they decided to do a terminal strip as opposed to just soldering new wires to the speaker. I will revisit that. I'm going to cut these wires a little bit short so I don't have something dangling on the bench. These are not the original wires, so I have no compunction in doing that. Original filter cap we're not going to replace with the same size. We're going to do some internal caps instead. We can leave this outside of the amp for cosmetics, for those who like such things. And the power transformer is beginning to come up and off and fail. You can see the chassis has been deformed there, and the flanges are all deformed. So I'm going to remove these. You can see the hardware is loose, and try to flatten out the flanges and reattach all this with some reinforcement washers. It's a fairly large transformer for a chassis this size, and it's just hanging down, so we want to take that stress out. That'll be one of the first things we do probably. It's just held in place by these two screws, so that should be pretty easy to do. Once that power transformer is held in place better, we're going to turn our attention to all the electrolytic capacitors. We'll get the transformer set up first. Alright, the screw's out on this end, and you can see how messed up that is. Let me see if I can get in here with these pliers and just start to straighten that out. Now the issue is when you do this thing, once this happens, that metal in that area gets weak, so I'm trying to be very careful not to snap it. And I want the bend to start closer to the body of the transformer, to the frame itself. I know you can't see all this, sorry. Sometimes I gotta favor the actual work over what the camera sees. I'm trying to very carefully bend this and get it closer to flat. And we're going to reinforce it with some new stainless washers in just a bit, which should help make it go flat and stop this from happening again. The trouble is that the bottom of it has gotten very concave, and if I use too much force, I could snap something. So I don't want to do that. I can use the new steel washers a bit to force things to go where I want them to be and flatten out. I think I'm going to try to do that because that's a much more consistent application of force. But this gets us a lot closer. Let's see what the washers do. All right, I've got it mostly tight now. I've got two good quality stainless steel screws here, two stainless steel washers here, a stainless steel screw. On the other side, I've got a thicker stainless steel fender washer to spread the force out over a wider area, and then a stainless steel nylock nut. As I further tighten this flange should flatten out. Let's see if I'm right. Hopefully I am. This makes the contact be over a much wider area. Just a lot more surface area, a lot of torque, and that's pretty damn reliable. It's still not as perfect as it would have been brand new, but I'm afraid to get in there and try to bend that flange anymore. The important part of it is very rock solid, and I'm going to tighten the other side to make sure that doesn't happen again. The other side looks much better, so I can just get in there and make sure the existing stuff is really tight. I have to move the camera to do that. When possible, I like to try to move the nut more than the screw, especially if it's a flathead screw. All right, that's pretty rock solid. And then on the inside of that reinforced one, you can see the fender washer. Not a huge one, but just the right size. And that nylock nut, and that makes me feel better going forward. So let me gather my thoughts and gather the parts I ordered and get started on the cathode bypass caps, which are electronically simple to change out. Mechanically, as far as how this is constructed, it's a little bit tricky. So let's see how we do. I guess it'd be better if you saw it in focus. All right, time to get started. In here, some of the old capacitors are piggybacked onto resistors, and others have the resistors piggybacked onto them. And in certain places, the lead of the capacitor is used for structural support. So I went with these 50 volt Sprague atoms, rhymes with vague, Lyle. Not because they're superior capacitors. They certainly cost more than a lot of comparable cathode bypass caps, but because they have very thick leads. So in this case, they are superior for our purpose. In general, I use Vichy capacitors more. They're better spec for less money, but they do have, or tend to have, unless you spend for the crazy ones, fairly thin leads, and these thicker leads will give us more support. Pet peeve of mine when vendors bend everything so it fits in a plastic bag better. It's really hard to get the bend out without introducing wear and tear. You just gotta kind of slightly press it flat. I'm sure there's some tool for that, but I don't have it. Anyway, I'm going to start by removing this 10 microfarad, and it's not going to be reused in the amp, so I'm just going to go to the side to give myself some access. Now I remember where those leads went. I'm going to start with this one, and I don't think I can show this entire process because the camera needs to be right where I am, but I'm going to disconnect wires from the capacitor. And you're out of focus again. So we've got a wire going to this capacitor lead, to this resistor lead. The resistor lead is wrapped around there. In this case, it's just wrapped around here. So this one will be the easiest one to do, assuming this resistor is good. What I'm going to do is I'm going to remove this capacitor from this resistor, making note of the positive side, which is to the right. And I believe, yeah, this is the output tube. So this is the cathode bypass resistor for the entire amp. I may, in fact, I'm very sure that I will not put the new capacitor attached to that lead. I'm going to run it in parallel, but I want a little bit of distance between the capacitor and the resistor. Even on a single-ended 1 EL84 amp, that resistor can get kind of warm and can bake a cap. So also probably will end up changing the value of this resistor unless the owner can guarantee that the amp will ever only run with 110 volts coming to it. So let me get started. One stray drop of solder hit the plastic and melted it. So I'm not sending this out into the world. Electronically it's fine, but visibly it looks like I just don't give a shit. And that's not how I roll. Well, I thought I was close to finishing up the initial wave of stuff, and I was taking some bias measurements before I showed you guys everything that I've done. And I only got 5 volts on the plate of this EL84 that's coming through the output transformer. So I don't know whether there's a problem with the transformer because there's voltage on the other side of it, or whether there's a problem with this EL84. But look at that plate. It's flashing and dimly glowing. I've never seen that before. So let me power this off and put in a different EL84, because that'll be the fastest way to find out. Now, how hot is this? It's hot as can be. It's really hot. So try to do this without burning myself on camera this time. Come on. These retainers are a menace when things are hot. This is a very old EL84, so it's more likely to be the problem than the output transformer. But, you know, we won't know till we know. I'll put it to the side and see what I have handy in my stash. Here's a JJ laying around looking to be put to work. So now a note, this amp, as it came in, as originally built, has no fuse. I've got my current limiter on. Later I'll be installing a fuse. I'll set this power on. And I'm going to be checking the plate voltage on that tube. It should come up pretty quickly, given that everything else in the amp is warm. It's only cycling to about 3 volts. That's it, and there's the flashing. Oh, interesting. If I turn the volume of the channel up, the flashing happens. If I turn it down, it goes away. Is it affected by the tremolo intensity? Speed, rather? Yeah, it is. So something really funky is happening here. That tube is not operating happily. I hear nothing in the output of the amp. So there's no signal passing out. I could have a terrible oscillation somewhere. So I will revisit this once I have solved it, because this thing's physically awkward to maneuver on the bench, and I just can't do that while filming. It's just too many axes in the air at once. Well, now I wish I had kept filming, because I found it pretty instantaneously when I went to measure the voltages here at the output transformer. This is the B plus going to the transformer. This is the yellow wire going to the plate. And if I physically move this connection, I can make it come and go, make the signal cut out. So it's a bad solder joint. Let me fix that and we'll get back to where I thought we already were. Well, this is a much better place to be. I've got one terminal strip added right here, as you can see, which allowed me to put in these axial F&Ts instead of trying to find any tiny little dual section can cap on the market that's worth anything. I've got a 10 microfarad here instead of the 8 that was stock. No one will hear a difference there. Here and here you can see the new Sprague cathode bypass caps. One new cathode resistor there. Here, this is a 162 ohm resistor on the EL84, and that is setting the bias at about 9.5 watts, which is a bit low. I probably be replacing that resistor, and because I damaged the Sprague that was going to go there, the one that was going to go here is actually there, so this is a tempt-in one. Tomorrow I'm going to get a fuse holder for this amp. It has no fuse holder. That'd be nice to have. I'm just going to do a little inline thing, and I'm going to pick up a couple of different value resistors for this, and one more Sprague to match the other two. I'm not convinced that all the resistors in the amp are good. The EF86 seems to have very little gain compared to what it should have. I mean, here it is. This is dimed. And it's just a little 4-watt amp, and that was just a single coil, but an EF86 ought to have a little more oomph than that. And I know a couple places in the circuit where they intentionally handicap the AC4 and the AC10 for that matter compared to the 15. So I may be able to get it a little bit healthier sounding than that, a little more grit available. The tremolo works. The amp only has trim on off and the speed. The depth seems a little bit high to me. That may be an old divider resistor that's been drifting in some unpleasant ways. So that'll be something I'll be trying to sweeten up as well. The tone works fine. Pot just needs to be cleaned. All the old tubes seem okay, though I'm not convinced that the EF86 has as much gain as I think it ought to, but that could be some other factors. When I was heating up joints in this amp, it's a classic thing where bubbles would come out of this resistor, or this resistor has a crack in its epoxy at the end. So these two are prime candidates for replacement. I'm going to go through and measure some voltages and some signal strength and do a couple of boring technical stuff. I might even use the damn scope. But, the first thing I wanted to do is just make sure this amp had good electrolytics, that all the tubes were working, and that the circuit was operational. And then, as you just saw, the output transformer had that bad solder joint, threw me for a minor loop. I'm glad that was all that was. I think this amp will be sounding really great next time you hear it.